We're going to talk about metric conversions today. So we first have to understand what a base unit is, and this SI stands for Standard International. So Standard International base units is basically a system of metric units that all other units are derived from. So you can see here length internationally is measured in meters, mass is typically in kilograms, a gram is very small, so that's not all that common, time is in second, temperature is typically in Kelvin, which we're going to use a lot in this class. We're going to talk a lot about also the mole, and in this class we don't refer too much to the ampere and the candela, but those are all base units, and then we're going to learn also about prefixes, which then help us calculate things to and from the base units. So these are the prefixes we're really going to focus on. Mega, kilo, deci, centi, milli, micro, nano, and pico. So a couple things I want to point out. There's a lot of M's in chemistry in general, so you have to really be specific when you're trying to show somebody what you're talking about. So mega is a big capital M, milli is a little m, and then micro is this mu symbol right here, so it's kind of like a cursive U, so make sure you are utilizing that. Now kilo sometimes is a lowercase k or a capital K. It goes a little bit back and forth. Now this is a way to understand it using these 10 to the positive or negative powers. I find that is difficult for students, but that if that's a way you've learned it, you are 100% welcome to use that. I'm going to show you what I find to be a little bit more useful and a little bit easier to understand, and these are the only units you're going to need to know. So I put this blue line here and I call that the base unit, and that means that is basically the 1. Okay, that's where everything starts. So anything above the base or this line here is larger than the base, and anything below is smaller. So for example, when we're talking about kilo and mega, 1 kilometer or kilometer, we typically call that, is 1,000 meters, and 1 megameter is 1,000,000 meters. Okay, so remember, this meter is what we call a base. So any of these can be replaced with a different base. So instead of it being kilometer, it could be kiloliter, right? We could use that, or it could be kilogram. So it doesn't really matter as long as you know anything with kilo, and a base unit is a 1 to 1,000 ratio. All right. Now you will have to memorize these, so there are many different ways to do it. I have a whole bunch of videos also on Blackboard if you have different ways that it's committed to memory. Now again, anything below the base unit is larger. So in this case, our base unit is meter. And just like there's 100 cents in a dollar, there is 100 centimeters in a meter. There are 1,000 millimeters in a meter. There are 1,000,000 micrometers or micrometer in a meter, and then there are 1,000,000,000 nanometers. Now again, sometimes we see this written as 10 to the 9th or 10 to the 6th, and that's also perfectly fine, or even 10 to the 3rd here. You do what works best for you. However you want to memorize that. If you prefer to do this in terms of the negative exponents and you know how to do that, that's fine. I typically teach using these positive values. I just find it to be a little bit easier for students to understand. But you do need to have these memorized. You will have to use these all year or all through the semester. All right, now we need to know these metric conversions so that we can do use them as conversion factors to go from one thing to another. So how we're going to do that in this class is called dimensional analysis. This is also called factor label method, so you may have heard it called that. Now, this is a very specific method, and it is something that you want to understand now because we're going to use it a lot throughout the year. And this is a non-negotiable how you calculate these, okay? Now, I know some of you can look at metric units and convert in your head, and that's great, but you have to be able to write it and utilize this method. This is called chemistry math. Okay, so I'm going to go ahead and show you. You always start with the unit that you're beginning with, and you start and put that at the top. And I'm going to, of course, demonstrate this many times throughout this PowerPoint. And then the unit that you are starting with, you're going to put on the bottom of the first fraction bar, and the unit you are going to, you're going to put on the top of that fraction bar. Now, the idea behind this is it is canceling out, so you're ending with the unit that you're trying to finish with. Okay, now we are going to fill in these spots right here at the top and the bottom of this fraction bar with conversion factors. And a conversion factor is basically something that is expressed in two different units. So for example, 1 meter is equal to 100 centimeters. Okay, we could say 100 pennies is equal to $1, right? That is an example of a conversion factor. So we can write these conversion factors either way. 1 meter on the bottom, 100 centimeters on the top, or 1 meter on the top, 100 centimeters on the bottom. And you're going to learn what direction you need to flip it to utilize it in this dimensional analysis setup. Okay, so let me demonstrate. So first we're going to start with the simplest converting here. And again, I know a lot of you can do this in your head. I completely understand that. But we're learning this method so that we can then apply it to more complicated chemistry things. So please make sure you're doing it in this method or you will not earn points on test questions, okay, even if you have the correct answer. So we are going to be using dimensional analysis. So the first thing we're going to do is start with what we are given. So we are given 1456. And again, we want to review sig figs. That is 5 sig figs there. So we write the number in the unit. We're starting with meters, and we're trying to go to micrometers or micrometers. So you go ahead and put your fraction bar. The unit you start with goes on the bottom. We started with meter. The unit you are ending with goes on the top, which is micrometers. Okay. Now, some students like to go ahead and put a 1 under that to show the different fractions. Perfectly fine. You don't have to, but you can. And then you fill in your values. So you have to know the values to be able to do this. So I'm going to go ahead and put 1,000,000 micrometers in 1 meter. Now, what you do is when there are two numbers on the top, and when I say top, I mean top of the fraction bar, you multiply them, okay? When there are things on the bottom, you would divide them. But since the bottom is a 1, we don't even have to do that. So the math we're going to do for this is actually 1,456 times 1,000,000, okay? And that will get us our answer in the units of micrometers. All right, so you know you're always welcome to use a calculator in this class. You never have to do any mental math, but we're basically going to just move our decimal place over here. 6 times. 1, 2, 3, 4, 5, 6. Okay. And again, you're welcome to use a calculator for that. You definitely don't have to do that in your head. Now, no answer in chemistry is complete without a unit. So my final answer is shown here with micrometers here. I know I didn't write that very nicely. Okay. So this is what is necessary to earn points for this question. Having just this answer, you will earn 0 points. Okay. I start this from the beginning. This is how we do it. All right, let's go ahead and do another example here. We start with what we are given, 0.5730, and this is micrograms. Okay, this is milligrams, excuse me, I apologize. Micro is this U, this is milli. So the unit you're starting with goes on the bottom. The unit you are finishing in goes on the top. Okay, and again, I wrote that in the previous slide there. You can look back at that. And then we fill in our spots here, and some of you may like to put a 1 underneath. Not necessary, but helpful. So there is 1,000 milligrams in 1 gram. So you have to figure out the values here, how many are in each of them. One of them is going to get a 1, one is going to get the number. So there are 1,000 milligrams in 1 gram. Okay. Now we're going to go ahead and do the math. So as I told you before, when you have numbers on the top of the fraction bar, you multiply them. When they're on the bottom, they divide. So to do this math, you could do this, 0.5730 times 1, which I would skip, but you can definitely do that. And then I would divide that answer by 1,000. Okay, so what I would actually do math-wise is 0.5730 divided by 1,000. When it's on the bottom, you divide. Okay, so go ahead and use your calculator and solve for that answer. And your final unit is always going to be the unit that is on the top of your fraction bar. And again, these cancel out. When you have something on the top, something on the bottom of two different fraction bars, they cancel each other out. Okay. All right, so that was a simple base to prefix. Again, a prefix, it has something in front. A base is just by itself. Now we're going to go ahead and do prefix to prefix. There are a couple ways to do this, but I'm going to show you, to me, the most logical method. And again, you do have to, again, use dimensional analysis. An answer without work is not accepted. So 573 milligrams. Now, when this is prefix to prefix, which means there's no base unit by itself, I like to do a two-step problem and go to the base in between. Okay, so the base in this case is the thing that is the same, which is grams. So I'm going to go ahead and do a milligrams to grams conversion first. Okay, fill in my numbers here. So there are 1,000 milligrams in a gram. Now, you do not solve. That's what the beauty of this is. You do not have to keep rounding. If you do all your math in one step, then you have a more accurate final answer. So I don't want to see you getting an answer here. I want to see you continuing on. So milligrams is canceling. Grams is on the top. It goes on the bottom of the next one, and you finish up with what you're trying to finish in here. And there are 1,000 grams in a kilogram. Okay? So you have to know your metric conversions. Now, how to do this math? You could take your 573 and multiply by your 1 and your other 1. But again, those are 1s. I skipped those. So how I'd really do this is take 573. I would divide it by 1,000, get an answer, and click divide again by 1,000 and get your answer. Okay, so this is going to be a very small number. Okay, and again, my unit is always the one that's on the top. Okay, so look, everything here is what's required. You earn a point for this step, a point for this step, and a point for this step. So if you only have an answer, you don't earn any points. Okay, this is a different method of practicing a concept that you're going to use throughout the entire year, semester. Okay. All right, so let's go ahead and try this one now. Again, if you feel like you know what you're doing, go ahead and pause the video and try it on your own. So you write with what you start with, and you have to be very sure that you know big M is mega, because students will confuse that with milli. And so there are 1,000,000 grams in a megagram, real big. And then the unit that's here goes on the bottom of the next one, and we're finishing in centigrams. So there are 100 centigrams in a gram. Okay? So to do the math here, I would take my number and I'd multiply by 1,000, get the answer, multiply by 100, and then we can go ahead and see what we're ending up with. So that's going to move over 1, 2, 3, 4, 5, 6, 7, 8. So I believe the answer is 4, 3, 1, 2, 0, 0. I could be wrong on this answer. I should be using my calculator here. So if I'm trying on the calculator, make sure I'm correct. If I'm not, fix it. Okay? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I think I'm right. All right. So again, your unit needs to be the unit that finishes on the top. Okay? All right, so let's go ahead and do another example problem here. We have an experiment that is 0.0543 liters of ethanol. What is its volume in cubic meters? Actually, we're going to do cubic centimeters. Okay. Now, I am going to tell you here 1 milliliter is equal to 1 cubic centimeter. They are equal to each other, but we cannot utilize that right now until we're in milliliters. So I'm going to go ahead and take my 0.0543 liters and get that first into milliliters, and then I can go ahead and show my milliliters to centimeters cubed. Okay, and that's a 1-to-1. Now, a lot of you are saying this is 1-to-1. Why do I have to show it? You have to show it because this is what proves that you have changed your unit. I know it's still the same number, but these steps indicate to me that you know that conversion factor. Okay? And go ahead and finish that off. What I would do is take 0.0543 times 1,000. You could multiply by 1, but I usually skip that. So that makes it 54.3 centimeters cubed. And again, our units here have canceled out. Okay? You do not have to memorize this conversion factor. You will see it a lot. All right, so now we're going to look at how to work with cube roots and square roots. So it is a little bit of a different step here. So 340 centimeters squared to meters squared. Oh, I wrote a cube here. So first you focus just on getting from your prefix to your base, which is centimeters to meters, and you fill those numbers in, okay? Right now, ignore the squared. Now, the issue is you cannot cancel this centimeters and this centimeters out, right? Because you won't have the same amount. So what you need to do is actually square this whole conversion factor. And you don't have to draw these arrows, but I like to just show you how when you square something, it goes to every component. So truly what you're working with here, and you don't have to rewrite it, again, I'm just showing you for learning purposes, is 1 squared, meters squared, 100 squared, and centimeters squared, okay? Now, 1 squared is the same as 1, and then when you do this problem, how I would handle it, I would do 100 squared first, get an answer, and kind of fill that in here when you are working with it so that it's easier to do the math, okay? So if you take 100 squared and you get, let me make a pen here, 10,000, okay? So instead, to do the math here, I would take 340 divided by 10,000, okay, because it is 100 squared. So to do that, again, you're only doing that because of this squared factor, so it is a little bit different. So let's go ahead and solve that, and my answer ends up being 0.0340. Again, my unit is what I'm finishing with, which is meters squared. Okay? All right. Let's go ahead and try another one. This is a cube root, very similar idea here. So I'm going to start with what I'm given. Again, try to set this one up on your own. You can pause the video and always check your answer. Let's first focus on our millimeters to meters, which is what we want to work with. Fill those numbers in. And then we want to show our cube root. You do not have to show that, arrows that I've done on the previous example. It was just to kind of demonstrate to you. So how I would handle this was what I would do the cube root of 1,000, okay, which ends up being a pretty big number here. I actually like to just kind of cross it out so that I can remember to do it correctly, and that is going to be a billion here. So instead of doing this shown as it is, I like to take 0.097 and I like to then divide by this 10 to the 9th or this billion number, okay? And that will move us over a lot of spots. So if we're going to move that over 1, 2, 3, 4, 5, 6, 7, 8, 9 spots, this is a very small number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 9, 7. Now, is this feasible as a way to write it? No. It's probably a lot easier to write this in scientific notation, and your calculator may actually put it into scientific notation for you. The good thing is I don't care either way if you write it like this or scientific notation, so whatever works best for you, okay? But this is perfectly acceptable as long as you have the correct unit. All right, so we're going to talk about temperature now, and so we finished metric conversions. Having a good basis of dimensional analysis and conversion factors are really important to kind of set you off on the right track for the rest of the course. So temperature is basically how hot something is, and we know that heat flows from higher to lower temperatures, okay, all the time. So if you have hot water sitting in a bowl, if you let it sit there, it will eventually cool down on its own because it is evaporating into the cooler atmosphere. So units that we use, you're going to see Celsius a lot in chemistry. Now, we know in America we use Fahrenheit here. We're not really going to use that very much in class. What we're also going to be using is Kelvin. Now, you may see that Celsius has a little degree symbol, Fahrenheit does. Kelvin does not. Okay, so when you're writing that, just try to be, doing it correctly. You do not need a little degree symbol because it is an absolute value. So as you probably know, in Fahrenheit, water freezes at 32, water boils at 212. Just to give you a frame of reference, Celsius is 0 and 100. It is very simple to memorize. In Kelvin, we're going to be doing some calculations with those, but you don't have to memorize when it freezes and boils. Now, you will be doing a lot of conversions using temperatures, and the good thing is these conversion factors will always be provided for you on your equation page. No need to memorize these. You just have to know how to use them. So we're going to actually go right ahead and do a practice problem here. So we're converting 341 Kelvin, TK is temperature Kelvin, to Fahrenheit. So we're going to go ahead and look for this value. So first we have to solve this equation for Celsius. Go ahead and plug it in and then solve for Fahrenheit there. Okay, so let's go ahead and substitute that in. So 341 equals temperature Celsius plus 273. You probably know this, but I'm just going to go ahead and show you all the math steps in case it's been a while for you. So we're going to subtract each side. So I'm going to go ahead and do 341 minus 273. We get 68 equals my temperature Celsius. Okay? So I have 68 degrees Celsius. I'm going to go ahead and take that value in and plug it into my next equation here. So that is 68 equals my temperature Fahrenheit minus 32. Divided by 1.80. Now, when you have something on the bottom, we want to get rid of that. So I'm actually going to multiply both sides by 1.8 to cancel it out. 1.80. So 68 times 1.80 gets me 122.4 equals, and I like to just bring this down, temperature Fahrenheit minus 32. And then we're going to add 32. Sorry, I'm writing over top of this to both sides. So my ending answer without any rounding is 154.4. Okay? Now, you need to round to sig figs here. So this has 3 sig figs. We're going to go ahead and round it also to 3. So this is going to round to 154 degrees Fahrenheit. Okay? So pretty hot substance. So just, again, knowing how to use these equations is all you need to do. You will be provided with the equations. All right, so density, we're going to look at density. Very simple here. Density is mass over volume, and some typical units here. You're going to mostly be using grams per milliliter. You're going to sometimes see grams per centimeter cubed, especially for solids, and sometimes you'll see grams per liter. So you really need to recognize what you're using and what you're provided with. Okay, so it is mass divided by volume. You do not need to memorize this equation. It will be provided for you. Let's go ahead and do a practice problem. So we have oil of wintergreen, colorless liquid. It is a 28.1 gram sample. I like to immediately underline or circle and then identify the variable. That is my M. And it has a volume of 23.7 milliliters. Find the density. So density is going to be mass over volume. Let's go ahead and substitute our variables in, 28.1 grams and 23.7 milliliters. Again, it's a good habit to be writing your units in the equation. Very simple. We just go ahead and divide here. Okay, so my answer is 3 sig figs because these are both 3, so I'm going to go ahead and just immediately round this. The answer I get on my calculator is 1.18565, blah, 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 but I'm going to round that to 1.19, and my units, again, no answer is complete without units, grams per milliliter. Okay, the numbers can cancel out because you're dividing, but your units don't cancel out. So by writing your units in there, it helps you solve. All right, let's do another example here. A sample of gasoline has this density, so that is the D value. What is the volume? We're looking for V, and we are given our mass. Okay, so density equals our mass over our volume. I'm going to go ahead and fill in what I have, 0.718 grams per milliliter. My mass is 454 grams, and I'm looking for my volume. Again, I'm going to kind of simplify this because sometimes students have trouble solving for variables on the bottom. So I'm going to multiply both sides by V to get it out of the bottom. You have to do the opposite operation. So it is being divided. I'm going to multiply it. Okay, so I'm going to rewrite this as volume times 0.718 grams per milliliter equals 454 grams. Okay, all I did was just rearrange the equation. Now by doing that, I can then get my V by itself by dividing both sides by that value that is next to it. And why am I dividing? Because it's being multiplied. You do the opposite operation. Okay, so basically the math for this is 454 divided by 0.718, okay? And my answer here is, I'm going to round this to 3 sig figs automatically, 632. And again, that is volume, so therefore it is milliliters. Okay? So try that on your own. Make sure you get the same answer. All right, so let's try another example here of some dimensional analysis. Star of Asia sapphire in the Smithsonian weighs 300 carats. Again, that decimal point is important because that tells you this 0 is significant. What is this weight in grams? And we have a little bit of a conversion here. So I'm going to go ahead and start with what I'm given. And I know I can go from carats to milligrams, so I'm going to go ahead and use that by putting my carat on the bottom and my milligrams on the top. 1 goes with carat, 200 goes with milligrams, and then I'm trying to end in just grams, so that is a very simple metric conversion here. Milligrams on the bottom, grams on the top. Fill in your values and then solve. Now, how would I mathematically solve this? All I would take is 330 multiply by 200 multiply by 1. I'd skip the 1, but you do whatever you want. Get an answer, and then I would click divide and divide by 1,000. Okay, so please try that on your own, again, so you can ask any questions if you're not getting the right answer. 330 times 200 divided by 1,000, and I get 66. Now, we want that to be in 3 sig figs, so I'm actually going to make that 66.0, and that is my final unit, which is at the top, 66 grams. Okay, it's pretty heavy sapphire. All right, let's try one more example here. The dimension of Noah's Ark were reported as cubits, okay, and a cubit is being told to us as 1.5 feet, and so we have feet in meters. We have this in cubits, and we're trying to get it into feet and meters, so we're going to do basically 2 separate problems here. 3.0 times 10 to the second cubits, and we're going to get that into feet. I'm just going to put CUB and feet. So 1.5 feet is 1 cubit. Okay. I'm going to do the same thing here. 5.0 times 10 to the first. Now, some of you may not like to work with these numbers in scientific notation. These are super simple that you could just put them into normal notation, which is perfectly fine. You do what works best for you. Okay. So it's basically 300 times 1.5. That gets me 450 feet, okay, which you can see is solved right here. And then we would go ahead and do 50 times 1.5, which gets me 75 feet. Okay. Now, it's asking for this also in meters, so I'm going to go ahead and do one other little conversion here. You do not have to memorize any metric to English conversions, only metric. So I have feet, and we do not have a feet to meter, but we are provided with feet to yard and then yard to meter. So I'm going to go ahead and use my feet to yards and then my yards to meters. Okay, so there is 3 feet in a yard and 0.9144 meters in 1 yard. Okay, and I'm going to go ahead and do that again up here. I'm sorry, I'm cramming this in here. Make sure you provide yourself with enough space so you're not doing what I'm doing here. Again, make sure you try this on your own. So basically, to do this math for the top one, I would take 450 times 0.9144 divided by 3. Please make sure you're doing this in separate mathematical operations, or you'll get the wrong answer. I'm going to go ahead and put my final answer in 2 sig figs here. So 137.16 meters, but I'm going to round that to 2 sig figs and make that 140 meters. And then I'm going to go ahead and take that 75 times 0.9144 divided by 3, and I'm going to go ahead and get 22.86 meters, which I'm going to round to 23 meters. Okay? Hopefully that helped you understand that. Just a little bit of a different sort of unit conversion and showing you how to set that up.